Isn't this a pretty looking box? I think it's pretty. This isn't brown. This is green or blue or brown. Depending on what angle you look at it. It could be purple. This amp, when I first took it out of the box, I looked at it and went, wow, it's a nice little paint job it's got on it. And then I looked at the magnetic fan guards and I went, oh, them are going to make some noise. I learned a long time ago in a galaxy far, far away, these are magnets. They got magnets and a slightly conductive screen that goes in between them, and they catch any metal particulate that falls through. They don't drag on the air as much, but they have a tendency to get pulled into the fan blades, and they'll drag. The fan blades will drag on this metal mesh, and it'll make a ton of noise. But let's check this out. This is RO number 56. This is sent up here by my buddy Rob. He's just down the street over in Oregon. Just go through it, make sure it works how it should, and do what you think needs to be done. It came with 4 extra pills, which are in the box, thanks. So I thought I went through everything, and I'm glad you put this on the note. I had a gentleman by the name of Dennis. You guys all know Dennis. He was a legend, but how do I put this politely? Let me think about how I'm going to put this for a second. Dennis, in his world, the way he thought, I guess it'd be the best way to refer to it as rock, paper, scissors. Okay? So in a rock, paper, scissors version of life with Dennis, meth, lies, and self-appointed bullshit was his rock, paper, scissors. And every once in a while, the meth would win out, the lies would win out, or the bullshit would win out. Dennis was a tough one. Like, Dennis has gone on, and me and Dennis saw eye to eye. Dennis came to one of my breaks, and he won everything. Him and Bullet showed up with him, and they installed this mobile setup in his truck like the day before the break. And he was shooting out against guys with like 5 and 6 antennas. And here he's got a mag mount, a director on his windshield, and then a reflector in the rear of his truck on this little tripod thing. And he beat everybody. He was using a 4-pill and a 16-pill class and was wiping people out. I mean, I had nothing to do with the shootout because I was hosting the break. I just stood there and watched it, and I'm literally like looking at his truck, listening to what's coming through my radio that I'm listening to on a little headset, and then listening to the callback station call it back, and I'm like, what? I'm looking at guys with whole banks of super capacitors in the back of their truck and legit 16 pills that are built comp boxes, no relays and nothing. Antennas, they spent a lot of time mapping stuff. Dennis shows up with a truck he put together with Bullet Bob the day before and won everything. And that's back when I was giving away like $300 and $400 a class, right? So he won the 2-pill class shooting out on a 2-pill, 4-pill shooting out on a 4-pill. Then we had him shoot out in the 8-pill class, and he beat everybody in the 8-pill class with a 4-pill. And then he beat everybody in the 16-pill class with a 4-pill. Anyhow, Dennis sent me his 12-pill that looked a lot like this on the inside. I went through it, and that thing ran like crazy, right? I mean, crazy watts, and it was all butchered when it got here. I get on the phone with Dennis. He's like, oh man, did you find my transistors? And I said, well, I found a bag of HGs. And he goes, well, yeah, there's HGs in there, and then there's all the Toshibas I took out of it. I said, Dennis, there's no Toshiba. I sent it back. I sent his amp back in the same box, all the same packaging. I went through everything. Called him live feed, called him on Facebook, live videoed, went through every scrap of packaging. Like, Dennis, where did you put this in this stuff? No, it's in there. I think the day that he shipped me the amp, maybe rock, paper, scissors took place. I don't know. He never said anything more to me about it. I'm like, Dennis, I don't have your transistors. Do you want me to fix the box, or you just want me to return it? Oh no, get it fixed. I gotta have it back. And he put it in there, and he was seeing numbers out of his mobile that he's never seen before. He talked a ton of skip on it. Meanwhile, he's running around telling everybody I stole his pills, and everybody's calling me like, dude, did you steal Dennis's transistors? I'm like, no, Dennis is high. And everybody laughed and went, yeah, okay, it's Dennis. you're gonna send me pills, you guys, let's like attach them to the amp with like blue painter's tape or something, not let them sit around free in the amp or in the case in the box. So, Rob, thank you. Sorry I went on that little spin about Dennis. Yeah, we don't know what got Dennis. We don't know if it was rock, the paper, or the scissors. But Dennis went on to God. It's pretty sad. Because when Dennis was straight, he was a pretty right-up guy, but the time with Dennis wasn't that straight that often. I think I got a couple more of these magnetic screens, because this one here is broken. As we can all clearly see, it's been ripped down, and if I turn the fan on with that fan guard running like that, it's just going to suck it right into the fan, and it's going to screw everything up. See how that's... Come on, honey. All you got to do is spread the lips out. There we go. We can see that's a little off, right? Like I said, I used to use these religiously on things, but then they got really, really expensive. Yeah, oh, hey. Hey. Right on, okay. These got really expensive, and then nobody wanted to pay for them. And they're really delicate, like they're super easy to tear. So, what I was doing is I'd use and see the holes in these aren't quite big enough. Sorry, do this all the time. Holes in these are quite not big enough to cause a lot of drag. But this is hard enough and flat enough that we can put this between the fan and the, like so, and it's enough to stop your finger, and it's enough to keep itself out of the fan guards, and then we put these on the bottom. But I do have an extra one of these, thank God, and we can get this fixed up for you. It's not a problem. And then after that, then I started putting these on everything. So then I went to these, which work really good, but once again, the size of the hole made it drag a little bit. And then I went to these, the black fan guards, and then I had a nice gentleman, really super nice gentleman that makes these for me. So, you know, kept a couple of these laying around, kept a bunch of these laying around. I only got 2 or 3 of the all black fan guards, but you know, I got spray paint and Scotch-Brite. I can create more of these if we want. But these don't work out so hot in the pull-in configuration, the way these are set up. They just get sucked into the fan. But they're the best at stopping all little molecules of crap and not interfering with the fan airflow itself. This doesn't feel like, to me, it's done for some reason. I don't know why. Just putting it out there. Let's see, the fans are put together right. I've got glue on all the screws, and I got the little 1.5 ohm resistors to lift it above ground. So that all looks okay. Let's take a look at the inside. So this side's pretty clean. This side has had something spilled on it. We can tell. Look at all the schmuck that's on the board here. Now, we wouldn't have this problem if whoever built it, they would have put clear on it. So we'll take alcohol and we'll try to get all this cleaned up. But yeah, I mean, this looks like a hopper built in a way. The things that cry out to me that we need to change and pay attention to would be these output caps. We've had these fail a lot over the years. Like, I got a whole Ziploc bag full of these 1,000 and 500 volts. So they come in 2 volt ratings. They come in 500 and they come in 1,000. I love how they did the heavier wire. That's awesome. That actually does help the box put out more. Anyhow, these caps fail pretty often. This might have been built when we were having a hard time getting a hold of the metals, the 1,000 metals. And at $8 or $9 a piece, I got to see if the customer wants to put 10, 20, 30, 40, 50, 60 extra dollars in the box. I don't know why they wouldn't, but they might. They might not want to. And the other thing that cries out to me is this. See how long this is? And you see how long this is? This is about the right inductor length for the output, but not with this long a wire. Just change point of views. We want our capacitor to be here at the relay. We don't want it way back here on the inductor. We want it here at the relay. So I can move this, like I can unsolder this, and move this. But I can bet you almost when we get to the proper tune length on these, this coil is going to be pretty short, if non-existent, and the same definitely on the input. I bet you that we don't even have a quarter of a hoop on this. Big heavy-duty relay, just a bunch of little small things. I mean, it looks really good. It would help if we put a capacitor from here to ground, which we might do, but this looks really good. Whoever put this together actually cared. To have this 12 gauge here versus 16 or 18 gauge wire on the power really helps. Like really helps. Maybe this will come out in a video. Maybe you guys will be able to see it. I don't know. Here, let's see. This is all nice and white, and these are all brown. So something got spilled. So we'll throw some alcohol on that and we'll get those cleaned up. Yeah, see, there's even goop up here in the pill holes and stuff. So, good caps. Good caps. Electrolytics, that is. And we took the power wire underneath the board. I need to find out if he wants to extend the power wire or what he wants to do. We've got good PL259 panel mounts. Nice solid copper bus going down to the bar for the ground, or the board for the ground. There's a lot of good here. More good than bad by far. By far. So there's no name on this thing. So whoever did this, I say good job. And what we'll do is we'll end up putting a BBI sticker right over this hole. That way we can get air to actually move in and move through. I don't know if these are scratches or some idea of like leftover fun juice that's on the front of this thing, but we'll figure that out. But we'll get it all cleaned up. This does not look half bad. Believe me when I tell you. I mean, like I had a guy send me, oh my God, can you believe how bad my amp is? And I started sending him pictures of some of the stuff I've worked on. He's like, holy shit. I'm like, yeah, dude, your amp's not that bad. This is not that bad. This is actually really, really, really cool. Yeah. I'm debating if I should hook it up and run it, or if I should just go ahead and jump into it like I normally do and start doing mods. I think what I should do first, though, it is 2:15 in the morning, and it's about time for me to go to bed. I think I'm going to wait, and I'm going to call him tomorrow and see what he wants to do, so we can have a general idea on what needs to happen. Yeah, I need to get out the network analyzer. We're going to have to add some 50 ohm dummy loads to the ends of things, and we're going to have to test these tuning coils, because this long ass inductor, we normally like to sneak and have them right about here. Right? Have them right about here. The same thing with this, we like to have it about 2, maybe 3 inches away from the relay at the most. So instead we've got a solid 4 inches, 5 inches worth of inductor, and then another 5 inches worth of inductor. And this is just way too long. I mean, this is way too long for this to be natural. They're resonant for the 27 megahertz band. So, okay. I've said words. We have intro. I've looked at, I've evaluated. I have comments for our owner. See you guys tomorrow. Okay, so we are going to attempt to update this thing to a 16 pill, straight across. So, we already pulled the output tuning tube from this side off. We're going to pull the combiners off. We're going to pull the splitter off. We're going to pull this off, this off. We're going to get rid of all the power wires just so we have room to work, number one. Number two, we're going to upgrade them. We're going to try and stick, the only piece of coax I need to extend is this one here. And when we move the combiner over to where it's something a little bit more realistic, we'll be able to get the extra slack to bring this out and around. It's pretty easy. I got a couple transformers over here that we're going to use that are material make, size, and unit Henry match. Got the 4 transistors here, which we're going to beta check these, HFE check these here in just a minute. So first, let's rip it down. Let's take everything out that we don't need. We're going to pull all these caps out, here and here, 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 and here. Get some combiner, get a combiner and a splitter built up. Get some pill strips cut and get that ready to go. Get some 10 ohm resistors. We're going to match the 2 watt resistors all the way across, except for over here we're going to convert these up to 5s. Just cuz. And yeah, let the madness begin. First to come off is the splitters, the splitter to combiner, power wires, that kind of thing. So away we go. I tell you, this getting old thing is interesting, man. My entire life, my idea of a good day would be get up at 11 o'clock, maybe noon, and go to bed at maybe 2, 3 o'clock in the morning. And man, I'm telling you, here lately, I've been doing this thing where I've been going to bed at like 10 o'clock in the evening and getting up at like 3 o'clock, 4 o'clock in the morning. It is 4 a.m. at the moment, and we're going to continue on with what we were doing yesterday. So as far as we got yesterday, and it's weird, I'm up and I'm kind of with the day, and I'm thinking about how I'm going to get IHOP this morning for my wife to eat when she gets up to go to start her day in a couple hours, and I'm like losing it. I'm like, what the hell? It's weird. Okay, so where I left off yesterday is I got this whole 4 pill section completely built up, and as a practice and skill of art, I went ahead and did everything I could to copy whoever built this box. It's still a little bit yet to be undetermined in my mind. Whoever built this box, I'm copying their build style. So, I mean, I don't see a lot wrong with it. Of course, it's not an actual BBI build, but we're going to put the BBI machismo on it, right? So, we went ahead and we just copied it literally down to the transformer, the cuts on the transformer, the nuts and the bolts, the hardware, literally putting the, like if we look down here, we'll see that there's a little phenolic board down here. I went ahead and I copied that over here. Copy exact material makes, the same wire wraps, same wire size, same components. I dug around and I found some 104Zs, because these are 104Z caps, just 104s. Found everything matched. Right? And I was like, holy cow, I can't believe out of this myriad of stuff I've got here, I had exactly what I needed to make this thing happen. Like I was saying yesterday, we went ahead and we replaced all of these caps. They had 2 500s put together. We did go through a thing a couple years ago, guys, where we couldn't get these metal caps. And thank God for Fat Boy, Tony over at Fat Boy, who was willing to persevere and put up the money. Listen to me when I say this. And he put up the money to go buy these in bulk and then sit on them and slowly sell them to us, because this is a very expensive bit. These caps are very expensive, right? $6, $7 a piece, right? Well, when I show up, I buy 50 or 100 at a time. Most people don't do that. Most of the builders would be like, I'll take 5 here, I'll take 8 here, I'll take 6 here. So he's got to go and put up, you know, shell out the $15,000 or $20,000 and then sit there and be willing to sell them to us at a reasonable rate. I had another friend of mine that had metal clad caps. I helped him get a whole bunch of them, and then all of a sudden he's turned into the Stigler and he doesn't want to let go of the caps at all. I was just down in his shop here a couple months ago and I was looking at, I'm like, oh, look at all those caps I helped you buy. Shame you don't want to sell any of them. Like 20,000 caps. It's ridiculous, but he just seems to think that they're going to get more valuable with age, and what he's not wanting to compute in his head that we've went ahead and we moved on, right? The company that manufactures these for us will make them in any capacitance value we want, any kV rating we want. We just have to be able to buy enough of them to justify them making a production run, right? So we've got these. We've now ventured into making A different value cap. Tony's now got them at 1,150, depending on how you build your box. Those caps might actually work better for your tune. We got another one that he's getting ready to come out with here pretty quick. I believe they're 150s at 1,000 volts, so 1 kV, and then we're going to do a couple kV version of that. Needless to say, doesn't matter. Back on topic. The tune on this, I'm not digging it so much. It's 150 here, 1,000 here, 1,000 here, and then 180 here. We figured out quite a long time ago that doesn't work too stably. But we're going to try this the way it sits. I want to run it the way it sits and see how well it runs. But I have a feeling I end up changing this cap. Yeah, like this cap here and this cap here, and definitely these. We'll drop these back to 560 and we'll watch the watts come up. But went ahead and built our brand new 4-port combiners yesterday and got them ready to go. I really like this standoff idea with the nylon. These are 2 just regular old solder tabs that are held in with a 632 screw, and then this is threaded nylon. I was like, that's it. It's a fun, easy idea, and it allows us to elevate things up off the board. So, if you can remember back, I was talking about in the initial portion of this, let me grab this out of my myriad of parts. This is our initial output, or input splitter circuit that was sitting way over here all by itself, and the combiner was way off in the corner. Well, I had to free up this one piece of coax to make it so I could build this 4-pil section, because the way it was set up, this was kind of bowstringed across, right? So what we figured out is if I lifted up these leads, instead of having this combiner sit way over here, I can now slide this over, and we can scoot these wires, these pieces of coax, we can slide this over, and now we've got a difference in proximity. So instead of it sitting way over here, which like it was, we can just simply slide this over, get this closer, and then we can get rid of some of this inductor, because there's no way this is right. And the other thing that we want to do is we want to add our capacitance right at the relay. We want to take and eliminate as much of our inductor circuit, and what I mean by inductor is the wire, the conducting portion of the circuit. We want to get the capacitance as close to the relay as we can. I mean, ideally, if we could, we would flip the relay around, believe it or not, and we'd have the wires come like directly off onto the tab and then directly off onto the capacitor, or onto the coax connector, and we'd have our feed point over here, so it'd be closer. But nobody builds like that, because it's completely way more work than the amount of efficiency that we're going to pick up. But still, this 3.5 inches, 4 inches, wait a minute, there's going to be some man girl out there that's going to claim foul on this, and it's going to say, oh man, I called that right on the money. It's going to say that that's man inches. It's 3 inches on the button, by the way. Right, so we're not talking man inches, because man, that's 6 inches right there. That's man inches, 6 man inches, right? When in reality, that's 6 man inches. Like, oh wow, look at that. We got a honker, man. A 4-inch wide hand, you know. Sorry. I know you guys are getting tired of hearing the dirty jokes. I know, it's just my shtick. It's the thing I do. It rolls out of me naturally. Forgive me. We're gonna do the same thing over here on the output combiner, where they had it sitting way over here. We're going to go ahead and we're going to unsolder some of these leads, and we're going to snuggle this over a little bit closer. That allows us to be able to cut this inductor down. Here's the inductor that was stock initially in there, and it's also got a 3-inch man lead, because this is where our capacitance was at, right? So let's measure this so nobody can call bullshit. 3-inch lead. Lead. So we want to get rid of that. That's too much. It's too much wire length, and we'll never get it to tune out properly. I should actually do a video on that, how to actually tune one of these properly. But then I think that some of the other builders out there that have spent a nightmare of time figuring out how to actually tune a box properly would make them actually drag me up on a cross and start sticking me in the side with a spear. They'd be like, "Damn you, BBI! That's the one secret I've never given away on video, is how to properly tune the output network. Because everybody's got their own little slight opinion on how it works. I don't know. I just read what was in a book, and then I've traveled around and literally looked at every amp builder and watched them build in the United States for the most part. Anybody that's, you know, big enough to warrant my attention, but they've all got one common theme that flows through everybody's tuning systems, which I think is cute. It gets us to here on the circuit and here on the circuit, and from here and here on the circuit. The main thing that you need to focus on for the actual tune of the box, because this is all fixed. We can't fudge these things here. But the main thing that we can play around with is here. Is, you know, from here to here, we can play with all of this, right? And this capacitor is a variable. This is a variable. Our windings are a variable. This is a variable. These caps are a variable to an extent, right? But we're going to slide this over, bring this over and shorten this up. So that's what I'm going to work on next. So I'm going to get our brand new combiners all put together this morning, get them mounted down, get our input coaxes run. I don't like doing this, but I'm going to do it anyhow. This is not my jam, man. I don't like to have the output and the input coaxes cross. It's like in Ghostbusters, don't cross the streams, you know. That's the way I look at it. It's the way I think about it in my mind, my head, my brain. I don't like to do this. Normally I would take this coax and I'd run it back around the box this direction so the outputs and the inputs don't ever cross. And I like doing it this way. I like having the power wire underneath the phenolic. A lot of guys, they don't want to drill the holes. It's not their build style, and they'll run the power wire over the top. That's not my thing. We've got ourselves the nice graduated copper plumber's tape here in the corner for our ground bolt. I'm probably going to pop that off and change that here in a minute. Have faith that shit will change. And then we're going to put some nice twist lock welding leads on things. And yeah, so this is done for the most part. I don't have any yellow Teflon, and I know I did. I had a whole bunch of it. God help me if I can find where I got off to. So we might have to live with one piece of orange, but I really want to make it match so it all looks period correct. I don't know why. It doesn't help with function whatsoever. It's just me being me, right? It's the ADD OCD that I've got going on, I guess. Okay, moving on. We are going to do a massive power wire upgrade too. We're going to do our big choke system and run the wires over the top, and it's going to, you know, it's going to look awesome. Okay, I'll be back. This is like the song that never ends, right? So I got to build up a ground strap to come off the back of this thing, and we're going to do welding leads as our connector. And every time I show this on video, there's inevitably somebody in the comments in the doobly-doo. Oh my God, you soldered the eyelet. It's ruined. The wire is death. You've destroyed. I got in a big debate a few years ago on solar system DIY RV off-grid solar system thing, where we talked about crimp and solder. So when you crimp your eyelet, if you have the right size die in your little hydraulic crimp, and I've got the big one and I've got an air driven one, and this is all I need for this one deal. I look at people and I go, okay, I understand your logic. I also understand nothing is actually perfect, but your logic only works in a perfect world. So the logic that some people have, and it's true, this is true. If you have your die correct, and you pinch your hydraulically pinch, not here I'm going to put this in a block, a V block, and whack it with a hammer, an actual hydraulic crimp. In theory, it's supposed to make a pure cold weld. So we compress the wire strands themselves, and then we compress the copper jacket around it with enough pressure that it becomes a solid. So you have a cold weld. And I'm like, great, that's awesome. That's good in a perfect universe. We don't live in a perfect universe. No hydraulic crimp is going to be absolutely perfect, ever. And we're not talking about that the eyelet's got a long enough sleeve on it to where we can do 2 crimps. to where we crimp it this way, then we rotate the crimp and we do it this way. That's a much better connector. With this style of eyelet, I do the hydraulic crimp, so in theory we have the cold weld, but then on the back side of things I'll drill a hole in the eyelet and then I'll backfill it with solder. So you think about it, we do the hydraulic crimp, and then right past the hydraulic crimp the little wires go poof, and they fray out inside the connector on the back side of the eyelet. So this would be what I consider the front side that would feed the wire, or this would be the front side anyhow. In the middle we have drilled this hole and we backfill this with solder. So where the wires go poof, and they fray out, now we're putting the electronic glue in there. So we have the cold weld, and then on top of that we have the actual electromechanical connection of having solder added to it. Everybody goes, but that ruins that. No, it doesn't. If you've done your crimp properly, all the solder stays on this end of the wire and nothing migrates back this direction. The problem that we have is that most people don't know how to solder, or will add too much solder, or they don't do their crimp properly, and the solder will wick itself back through the strands of wire, the little micro, because there's always tiny little gaps in the wire lead, will wick itself back and it'll make a stiff point in the joint where we can see this is still very flexible. Okay, will wick itself back and then make a stiff point in the joint, and then that will break. Or if you do this technique properly, it'll actually, because there's more metal mass and you have more surface area, you're adding to the surface area of the crimp on the other side, but an actual lower resistance level allows us to have a little bit better conductivity. So then on top of that, to help bolster this joint, just this area is all we're trying to support, we'll take and we'll put ourselves semi-hard marine grade heat shrink. So we heat this up, this heat shrink, it's got glue in it, and it gets hard when it cools down. So the glue shrinks up. Now we're adding to the situation a little bit of ability to keep moisture out of the wire, which the moisture entering the shoulder of the joint where the eyelet and the jacket meet, has a tendency to cause way more problems than the solder. But if you do your joint properly, you still have flexibility here because none of the solder wicks back the eyelet. And then we put marine grade heat shrink, which does two things. It keeps the moisture out, which keeps the conductivity up. And then the second thing it does is when this cools down, this gets fairly stiff. So now we mitigate the vibration, because this thing in a mobile, it's going to be sitting there vibrating all the time. Very small, not dramatic like this, but very small. This mitigates the stress that's applied to the joint and spreads it back here to where there's absolutely no solder that it could have ever gone through, and we still get all of our wire flexibility. See how that works? So it's proper preparation, proper application of solder stacked on top of, okay, now we're going to go and try to mitigate another problem, which is moisture into the wire, and then on top of that we get the side benefit of having the joint supported. So then the eyelet, in my opinion, can carry more juice, but it's safe. That makes sense? Just putting it out there. Let me assemble the rest of this. So this little tiny piece of brass, which has been flared on one end, is called a ferrule. You can take the wire and shove it in here directly, but having a ferrule in play actually allows us to have a reusable joint. So take the ferrule, we slide all the wire inside the ferrule. You see that? You see how it works? Now we take the ferrule and we slide that inside of the welding lead connector. So we hold the ferrule tight, and now we crimp down with the twist lock welding lead like this. Now we're going to really start to ramp the pressure up. And now we're achieving two things. The ferrule's keeping all the wires in place. It's evenly spreading out the compressive load that's being applied to it. And, I mean, like, we got to put some pressure on this, right? There. Now what happens is, in turn, you can see the ferrule is crushed down. But for any reason, if we ever have to take this apart again, we can undo the Allen bolt or the Allen nut and slide this apart, and we can move this around wherever we need to, and then we can put it back together again, because the wires will splay out inside of the ferrule, but the ferrule will stay in place and keep pressure on the wires and keep it nice and neat and organized, so we can reuse it again in the future. Very simple, right? You'd think it's simple. So the general rule is that we never use the same connector, right? So the hot is always going to be coming off the amp, and the idea is that we have a rule of standard, right? So on the amplifier we have our hot lead, which is going to be the pin, and then on the ground side we're going to have the female side of things, or pardon me, on the hot side, on the opposite side of the connector, we have the female side of things that we can push and log on to it, right? Well, on the ground side, we're going to use the female connector. So on the ground side, we have a male side connection. Come on, get it in frame. We'll have a male side connector for the ground side. The reason we do that is because the female side, we want to mitigate the amount of metal that's actually hanging out of the end of the connector. We can have this hanging around and it can touch stuff and we don't have to worry about nothing. This connector, if it was positive, if we had the post hanging out, now we're opening ourselves up to, when this isn't connected to anything, how much easier is it to get it to short against something that's metal? We have a big metal pin versus the other thing that we do is we try to create our ground lead so it's longer than our positive lead. For safety. Think about it. Just think about it. It'll make sense, right? All right. Let us continue on and not talking about this. Well, I don't know who built this, but I mean, like, seriously, we've got to have a conversation about, can you at least make your hardware tight enough that, Jesus. All right, let's back all this off and start over. You know what? That's my fault. This is my fault. I shouldn't be bitching at whoever built the amp. It's my fault. I should have guaranteed this was tight before I decided to start cranking anything down. So this is my fault. I shouldn't be bitching at the guy that put this together and couldn't get the nuts tight. My bad. Since we didn't have a lock washer, let's apply a lock washer and wow. Other people's children, I swear. Tight. Let's make it tight. You can experience life till you've got an intermittent connection there, and this sumbitch decides it's going to weld itself, and then you can't figure out why the power on your amp is going up and down in 3 ways from Sunday. Meanwhile, you're blowing transistors because the voltage is dipping out so low inside the box because of the high resistance of the connector. Because you're too lazy to make things tight so they wouldn't slip around. Okay. Moving on. Son of a bitch. Okay, so in review, this is the 316 mini coax that we removed that was coming from the 3-port splitter that was set all the way over here at the edge of the case, and we had input and output coax crossing, so we went ahead and we replaced all of this, and we replaced this. We just built brand new ones. It's not worth my time taking that all apart. Built new ones, slid the combiners over, changed how they're attached, went and changed the input and the output network so that they are much shorter, tuned them. Right now, I'm telling you, I got 50 ohms looking at this in reverse. If I hook up a network analyzer, and then I close the relay with this little hole that's in the lid of the relay, and I can look at the input network back to each one of its connectors, And that's this one here, this one here, this one here, and this one here. I got 50 ohms. And then from the input network from here all the way around to each one of its corresponding 4 ports, we got 50 ohms balanced as well. So when we go to light this thing off, assuming everything is going to work in here, what we're going to be looking at is the tune here. From this capacitor, these, and this one here. So the input and the output network has nothing to do with these. This is set up for balanced 50 ohm already resonant loads, here and here, at 27 megahertz, right? So now the playing of the tune, what we can do to adjust tunes, is going to be the capacitance values here and here on the input, which then in turn works with here, here, and here on the input. And then our output network, where we would do the tune change, if we were going to do any, would be at the metal clads, and then here and here, right? So on the output ports, and then at the output transformers. But we did a slight power wire upgrade. Which do you think is going to carry more current to each transistor? One run of 12, or the little run of 14 gauge or 12 gauge here, fed to the back of the transformer. Now this in turn, this does add some surface area to the front of the transformer. And if we were to measure it, the 90-degree turn that we're making here actually knocks quite a bit of the resonant field off. And turn once again the 90-degree turn here, and then the wire length that goes back, and then as soon as we hit the ferrite throws the wire out of resonance. But this does add more surface area to it, so we have to recognize that that's going to change how this tune works. I was on the phone with one of my friends, former student, now a very successful independent businessman, and he doesn't owe me a single thing because I don't remember nothing of me ever sitting in his shop pushing a soldering iron giving credit to his success. But I was talking with a friend of mine, and I told him what the tune was on this box, and I was like, dude, this is 180, this is 1000, this is 1000, and then that's 150. And he goes, with HG transistors? And I said, yeah. He goes, what, are we rocking early 2000s? I said, maybe. Like, we don't know how old this box is. We don't really even know where it came from. We don't know who built it. So we don't know. We don't know. I have a very strong feeling that I'm going to have to come and change these to either 750 or 550. And this is going to go down. I can almost bet money these 180s are going to need to go down a little bit. But we'll see. We're fine to the point now where we can hook it up and we can test drive it. We got rid of this. Like if we were to, here, let me change your angle here real quick. If we take a strong look at what this takes to actually get to true 50 ohm resonance, we have our little shorter bar that I like to add instead of pre-making the coil. I mean, it's, the wire length is literally 3 fingers wide. 3 fingers wide, right? We have a turn and a half. So the exact total length of the wire is probably close to 6.5, 7 inches at the most, maybe, probably 4 to 5. That's what it wanted. Same thing over here, just different size turns. We have a turn and a quarter, so then we go and we look at, let's see, this was output. This is our previous output network wire. And then they were adding capacitance in the middle of it. You can see this is much shorter. I don't know. I could insert here the network analyzer shot of the resonance of this circuit to show you what we're looking for when we go to actually look at the thing. There's a little bit more to setting up how to measure this circuit than just hooking up the analyzer and closing the relay. And I'm leaving that out intentionally. There are people out there that would lose their bacon if I actually showed how we go about simulating this, but it's pretty straightforward if you know what you're doing. Like if you know, think about it, you'll understand what we have to do to get that to where it measures out properly. So all we're looking at is this portions of the circuit. We're not looking at the capacitance combined at the end of the coax and whatnot. But did the power wire upgrade. I think we're ready to rock and roll. I want to hook this thing up and see if it works, or if the smoke comes flying out of it, or if we've got some dead sections or bad transistors or whatever. The customer through this whole thing have been sending him pictures as we've been going. He's like, well, do we know if it works yet? I'm like, no. He goes, why didn't you test it before you took it apart? And I said, why would I? So I'm going to change everything in here, like legit. Change the output network, input network, all that stuff, that's irrelevant. The only thing that we have to do is worry about if the transistors are working or not, right? Well, if I change them now or I change them later, change them in the beginning of the process or change them at the end of the process, really what difference does it make? It's the same amount of work doing it at the end than it is doing it at the beginning. Just saying. So, all right, let's put power to this thing. Let's see what it does. Okay, so I'm going to show this to you. This is the reason this tune is no good. And we had a lot of problems with the tune that's in this amp. Let me show you here. So we're going to hook up our ground side of things. Now, let's turn the amp off for a moment. We're running the base, or the workbench striker. We are on 12 volts. This thing underneath RF, I've been so disappointed in the last 2 volt amp gauges I've got, and I haven't been able to slow down. I was planning on doing it this weekend or something. I've been able to slow down and adjust this and get in here and mess with this to keep the RF out of this. Right now when I key this thing just goes right out to lunch. But when the amplifier is not keyed, the reading that it shows us, the 12 volt and the amount of current draw this thing is going to pull, is legit. Okay, so we're going to put hello audio. Let's throw our dead key up here about roughly a watt or two. About a watt. Throw a watt into this thing. Now, let's zoom back out. For an extra reference for current draw, I've got this hooked around ground. Okay, so we're going to keep our eye on this and watch what happens. Oh, I got the positive pulled out of the line too. All right, so let's shove the positive rail in here. Now let's watch what happens. Amp is keyed, and our reflect is horrible. That's with 1 watt going in. Now watch what happens when I come off the key. This thing is oscillating. It's making its own power. So we've got the input and the output networks are close enough in resonance that we've got RF passing through our harmonic suppressors, and we've got RF that is resonating just a little tiny amount to where it's going in a circle. And it's making its own power with the relay active or not. And that comes from this 1000 and 1000, and the 150 and the 180. They're too close. So now experience has taught me that if I go and I change this capacitor, this capacitor, this capacitor, this one, this one, this one, and this one, the oscillation issue will stop. But because we changed these caps here, we have to in turn change this cap, this cap, this cap, and this cap as well to bring the resonance of the input of each one of the four pill sections down. Okay? So when we change these, of course, this is going to change. We can't change this without changing these. Now we can play with this up and down a little bit, but this is our driving factor. So what I'm going to do is I'm just going to go ahead and I'm going to pull this back to 560. So we're going to cut the capacitance here in half, and then we're going to let it sit, and we're going to try this again. So the amp is working. All the sections are working. We can see that. We don't have a short on anything because we'd have smoke immediately. We'd have smoke and flames and issues. We're not seeing any of that. So we know that we're close, but because we've changed all this other stuff, what's it going to hurt us just to change out these caps and see if we can get the self-excitement oscillation issue to go away. Oh man, do I got this thing working good now. The oscillation issue, some guys like to enunciate it oscillation, I enunciate it oscillation. Oscillation issue is really hard to overcome. And sometimes it happens with the HT2879s. And it all a capacitance issue, by the way. It took several hours worth of changing parts, like here. Trying to put some air across this thing because I've been running it a little bit, but I had to change this many caps to get the oscillation issue to go away. I shouldn't have put them in a pile like that. I had them all separated into capacitance size so I could put them back in the drawers, but we're screaming here on power, on heat at the moment, so I'm shoving some air through the heat sink and letting some air go over the parts. We'll zero out the DC amp gauge. Okay, so first off, let's point out a couple things. We're running this on the 2,500 amp bench supply. When I was running it on this, I got to look at this supply. It's down. Anything over about 400 amps and it starts having a bad day. So we're just using it to drive the driver. We're going to use the striker, derail striker 955, run that into the bench 4-pill. The bench 4-pill then in turn with the 3-foot jumpers going directly into the 16-pill. Okay? So that's off. Look at this in average for the moment. We're cruising on 15.5. And here's what we're doing for drive. This is in a 1,000 watt slug in 5 times. So that's reading a 5,000. That's a 5,000 watt element reading an average. Hello. So we're going to put 400 bird in it from the bench straight 4-pill. Hello. We're seeing right around 1,000 watts of drive, which is perfect. This is our power supply voltage, 15.8, and that's tapped in here. This, the driver out of the way, is our amp draw. Okay? So we're going to completely ignore as we go. We're not going to even look at this gauge. Once I get this box done, I've got all day tomorrow. I'm going to sit around and figure out how to make this so it reads appropriately. Any kind of RF around that thing, this meter, and it's out to lunch. And that's why we're using the clamp over amp ring, and we're using this volt gauge here. These numbers are great, by the way. Hello. So there's our 2,000 plus bird. Hello. 360 amps dropping directly back to 0. And our voltage at the power supply distribution plate. Hello. 15.3 volts. Okay, now let's go over here and let's take a look at watts. It's a 5 watt slug in reverse. It's sitting here at milliwatt measurement, 5,000 in average, and 5,000 in peak over here. Hello, audio. According to this gauge here, we're seeing 43 to 4,400 watts peak. We're seeing roughly 2,000 bird here, and 134 milliwatts. So now let's change this over to peak. It's a 5,000 watt element and it's now reading in peak. 4,500. So now let's back this out so then we can have the full Monty, the full view. Tiny little bit of glare there. Fix that. I don't want to do anything more with this because we have no air on this box. And we're running it to full chooch. So let me now tackle the last problem that we have going on with this particular setup. And that's our fans. Like I covered in the beginning of this, and I'm telling you guys, this oscillation issue, I thought I was going to lose my mind. I've never had one fight me as hard as this one. I was on the phone with one of my friends. His name's Chris. He's like, man, I've never heard you struggle this long on one before. I'm like, man, I'm confused. I don't, it defies logic. So we're going to change these out. We're going to move these to the bottom side of the fans. They'll help a little bit. We're going to put regular fan guards up here on the top of this thing. Remember, this one's ripped. Yeah, see, this one's ripped. So we're going to replace this with a new one. So let me get this fixed up. So what kind of fans are these? Oh. Straight up made in China, 12 volt DC, brushless. No current draw. I don't know if these turn fast, they turn slow. They better be turning fast. Needless to say, this thing's running like a Swiss watch. Now, let me turn the driver off. And we're just going to go over to the striker now. So we're going to loaf this thing. No air. Dangerous. How much you want to bet that the first time I key it, those fans all go out to lunch? Nope, we've had it. We're gone. See ya, Dad. No more. All right. So, this is what we're going to put into it for drive. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2. About 100 watts. And 100 watts gets us about 1400 peak with 100 watts drive. So if we were to plot that out, 1, 2, 1, 2. If we were to plot that out, 100 watts drive versus 1000 watts drive, and we're seeing 2200 more watts out of it. I'm telling you, it's weird, but that's how they work. It's just how it works. All right, let me go here real fast, do my least favorite part of the entire equation. Let's play with fans. I hate fans. I wish I could hire somebody just to come in and install fans into cabinets, and then I just hate fans. I don't know why. I just don't like them. So let me go twiddly dink around with that for a hot minute, and we'll be back. I don't think this box worked. I really don't. Of course, we'll never know because I never tested it, but I mean, I have had to change everything, including the kitchen sink, it feels like, on this thing. Changed fan guards around. Got rid of our ripped one. All right. Tell me which one's the used one, or the new one, I mean. And then also tell me, if we look really close at this, what are we missing? I love the fact that we have our little resistors lifting ground away from the fans. That's hot. But what's missing? RF choke on the positive leads. I mean, you can put the choke, believe it or not, on both sides. I saw on a ham amp the other day that they had a choke just straight up. It was just on the ground lead. According to their engineer, that's the way it needs to be. And I'm like, okay, you say so. I believe you. I want to believe in your engineering degree from ITT Technical Institute or wherever. I don't, you know. So, yeah. Now we've got to figure out. Well, there's really nothing to figure out. I mean, these things are just so delicate, I swear. Tomorrow's Halloween. Did you know that? My favorite day of the year. Actually, it's technically Halloween now because it's 1:49 in the morning. I got to get up early. I got to start cooking. I'm smoking meat all day long tomorrow for Halloween. Because we always have a huge party over here on Halloween, by the way. I got to put chokes on this. Because if I put this on there, and the first time I key it, the fans are going to go, rah, 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 green giant. That's going to be it. Conversation over, story over, words over. And then I'm going to be out $44 for new fans. So, needless to say, give me a minute. Just effing give me a minute. Just 1 minute. I'll be right back. That sucked. I ended up using pre-wound, wire-wound chokes over Type 43, simply because the positive leads are so short. I have a very strong feeling. There's a reason that I ordered 40-something fans today. I have a very strong feeling that I'm going to key this thing and it's going to smoke these fans. So if it doesn't, we're going to be excited because we're done. If it does, we're going to be upset because we got to now put $44 more worth of fans into this thing. Three, two, one. Hello, audio. Yeah. Okay. Sorry, I'll be more professional. It worked just as planned, and please do not confuse my momentary breakdown of emotion there as being anything other than I knew it would work. Oh, 1, 2, 1, 2, 1, 2, 1, 2. Turn that over to 5 kW. Put that on peak. Hello, 1, 2, 1, 2. God, 4,800 watts. Puts out more with the lid on. Shit. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Audio, 1, 2. 2,000 watt dead key. Hello. 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 No oscillation? No oscillation. That was a trick, by the way. The workaround I came up with the oscillation issue, I'm sure I'm going to have to share with other people, and it's going to get spread around the country because this oscillation issue that's been going on with these HGs has been a little bit of a burden on some builders' hearts. I'm here to tell you, I'm free. I'm free of you. Sorry, I've spent 3.5 days on this. I could have built this in less time. What's taken the most time has been the oscillation. I spent almost the entire day working on that today. And yesterday I wasn't too motivated, but I could have literally built this in less time. Like half the time, right? But it's done. I got good pass-through swir. It's taking tons of drive. It's making more watts than it should. It's happy. Amp's happy. Radios are happy. It's happy. It's happy. It's all I care anything about. What's it look like on the monitoring radio over here? Hello, 1, 2, 1, 2. Here, check this out. So we're on channel 20, which is going to be over here. And if the amp produces a nice amount of harmonics, it goes, blows the whole scope out. But remember, on a sealed dummy load, this is just leaked RF going into the receiver here. 1, 2, 3, 4, 5, 6, and oh. Now, when we see the red start to appear on any waterfall, this measurement of frequency occupation is completely lost. So let's put 18 dBs worth of attenuation on this and see what we've got for frequency occupation. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Hello. Man, the box runs. When I say you lose any ability to have an accurate measurement of frequency occupation. Remember, this is not a spectrum analyzer. This is just a waterfall pan adapter. It's just a receiver that they're cycling on and off about 110, 150 times a second. Well, when the receiver gets overloaded, there's no built-in auto attenuation for each one of the times it takes a sample. So if the receiver gets overloaded, it doesn't know what to do with the extra signal, and so therefore it blows over and it starts to occupy more frequency on this display than what it's actually showing us. I know that's really hard for you guys to understand. On most spectrum analyzers, let's say like on your radio in your car, well, why is it that I can sit right next to a 50,000 watt station and it only occupies one, there's CAN filters and upper and lower traps that cut a lot of that out, but in the actual receiver unit itself, it's got an automatic attenuation unit. So with the attenuator off, once again, hello, 1 2 1 2. We're seeing about 20 kcs wide, which is not bad, but I mean ultimately we want to have 5 with 18 dBs of attenuation. Hello, 1 2 1 2. We're seeing about maybe 6, maybe 8 kcs worth of frequency operation or occupation. So that tells us the country bucket. So that's all I needed to see. I'm happy. Oh, I'm happy. Fans keeping up. I mean, I don't even have the sides on, so I'm leaking air out here. Got a big hole in the front, but the fans are keeping up. Hello, 1 2 1 2 1 2. Hello, 1 2. Hello, 1 2 1 2. I'm happy. I'm let this cool off. We're gonna let the air do its thing. This is the hardest this box will ever get run. Don't drive it this hard, by the way. The owner, don't. Remember, we're on Chinese parts. We're on Chinese parts, and just because it's working here, you might get it on your end, and if you try to drive it this hard, just saying. What we are gonna do to cover up this hole in the front is I'm gonna take a BBI logo and we're gonna slap it right here on the front. Now what I do need to do is I need to add on-off stickers, and I need to change the label on the front from reading 12 pill to, I'll say, BBI rebuilt into a 16 pill. This isn't a BBI built. Like, I got a guy right now on my Facebook group trying to sell a 64 pill that I took that was a 48 and I built into a 64. And he's out there trying to market it as a BBI built 64. It's not. It's a 48 pill that I modded up to a 64. I hope you guys can understand the difference. I don't know who built this box. I think it was my buddy Chris that built this, but I can't ask him, which makes me sad. That's another story, but done. Done. Ah. Whoop whoop. Yeah, buddy. I'm so happy right now. I'm really happy with the performance. It's really hard to get this level of performance out of the smaller transistor or transformers. And that's also another reason why the box runs a little bit warm. It's because transistors are getting saturated. Kind of makes me wonder what we'd get out of this if we'd use a little bit bigger things, like, just saying, I don't know. All I know is this is what I like. 49, 47, 4800 watts. PEP. Let's reach down here and shut that supply off. Shut this amp off. These things always take longer than what I think they will. Always, every single time. I know this, my floor is covered in little bits of wire and this, that, and the other thing. It's time for me to reset, clean the workbench up, get ready for Halloween, get this thing packed up and ready to go home tomorrow, contact the customer and tell him the great news that his amplifier works great and he's going to love it and he's going to be totally happy with it. Let's see. I am going to be doing a free amp giveaway to my paid members of my Patreon group. I announced this the other day, and I put on like 35 Patreons. The problem is that all the Patreons that joined are free. They joined the free membership, and there's nothing offered for that, right? It's literally the cheapest thing on the face of the earth. It's $1, right? It's $1. I'm going to start producing a ton more content just for the Patreon guys. I just got to say that out loud, and I'm going to throw that out to the public. It's just the way it's got to be. It's just the way it's got to be. These guys are paying for my attention, but they are the ones that make it possible that I can spend half my day on the phone with you guys answering questions and helping everybody out in Radioland. My phone number's right here. So, I mean, you got a question, anything I can do to help answer. If it's antenna, how to set up your mobile, any problems you're having with any kind of amplifier. At this point, I'm 4,000 plus videos that YouTube hosts for me, 1,400 public ones. There's knowledge. If you have questions, don't hesitate to text or call. People do it all day long. The Patreons are the ones that make that possible for me to do. Right? Because it's a huge dent to spend 3 and 4 hours of my day on the phone, but the Patreons make that possible. They help offset, right? They're the ones that help support the camera, the software, the licensing, the computer upgrade that I have to do every other year to stay current with things. That's the Patreons. That's what they do. And I thank them for it. And I'm loyal to them guys, legit. So if you want to be part of the free amp giveaway, which is going to probably take place here in this next week or so, come join Patreon. I'm going to probably start doing it bi-monthly. We're going to change it up. We're going to do a 4-pill this month. Next month it might be an 8-pill. It might be a 2-pill. Don't know. We'll see when we get there. But I know this to be true. I say thank you to my friends at Penna. I say thank you to my friends at XS. I say thank you to my friends at Siglent. I say thank you to my friends at Odyssey. Even my buddy Raz Schifrin over there in Israel, the owner of Perfect Pass. His sticker's right there. I say thank him too, even though I don't do RC anymore. Shout out to Bird, Coaxial Dynamics, Robert over at Steam and Coax. Thank you. Thank you. Okay, on that note, I'm going to set this aside. I'm going to sit down and edit the video, and it's time for me to think about going to bed. $4,700 watts. Cha-cha-cha. I love this part of the job. I'll see you guys. Thank you all. My name is BBI, the biggest mud duck in Idaho, and I'll see you. Click, click.